It is my pleasure to welcome you all to today's session on a topic that is not only timely but also highly relevant in today's interconnected and vulnerable world: terrorism and bioterrorism. The advancements in science and technology have brought us immense benefits, but they have also introduced new challenges and threats, one of which is the deliberate misuse of biological agents to cause harm. In this lecture, we will explore the evolving nature of terrorism, focusing on bioterrorism, its psychological impact, and how history has shaped our current understanding of these threats.
Let's begin with the term terrorism. At its core, terrorism involves the use of violence or threats to intimidate or coerce individuals, governments, or societies to achieve specific goals. These goals can be political, religious, or ideological in nature. Example 1. Imagine a group that wants to overthrow a government. Instead of participating in democratic processes or negotiations, they use bombings or armed attacks to create fear and force the government to comply. Example 2. Sometimes, terrorist groups might target public spaces like markets, transport hubs, or schools to spread maximum fear among ordinary people. The central idea of terrorism is not just about causing harm, but also about creating widespread fear, disrupting normal life, and drawing attention to their cause. Bioterrorism. Bioterrorism is a specific type of terrorism that uses biological agents like bacteria, viruses, or toxins to cause harm. The intention here is to either directly harm people, animals, or crops, or create panic and disrupt social and economic stability. Biological agents used: bacteria, Bacillus anthracis; viruses, Variola virus; toxins, botulinum toxin. Think of bioterrorism as a silent threat. Unlike a bomb that explodes immediately, the effects of bioterrorism can take days or weeks to manifest, making it harder to detect and control. Example: in 2001, anthrax spores were mailed to individuals in the US, leading to infections and deaths. This incident created panic and fear, demonstrating how biological weapons could disrupt society. Importance of understanding terrorism and bioterrorism. Now that we understand the definitions, let's discuss why it's important for us, especially as biotechnology students, to study these topics. Global impact on safety and security. Terrorism and bioterrorism are not confined to specific regions or countries. They threaten global safety by disrupting economies, healthcare systems, and social structures. Example: the COVID-19 pandemic showed us how infectious agents could paralyze nations. Imagine if such an outbreak was intentional. The consequences could be even more devastating. Public health implications. Bioterrorism targets healthcare systems, often overwhelming hospitals and causing panic. Example: a deliberate release of smallpox could lead to rapid transmission and mass casualties, especially in unvaccinated populations. Public health officials must act swiftly to detect, contain, and treat affected individuals. Role of biotechnology in prevention and response. As biotechnology students, you play a key role in addressing these challenges. Prevention. Biotechnology helps develop vaccines, rapid diagnostic kits, and biosensors to detect biological agents early. Response. Advanced biotechnological tools like CRISPR can be used to study pathogens and develop targeted treatments. Forensic applications. Biotechnological techniques can identify the source of biological agents, helping law enforcement track down perpetrators. Real-life connection. Let's connect this to a real-world scenario to understand its significance. Suppose a terrorist group uses a highly contagious virus in a crowded area. Without early detection, the virus spreads quickly, affecting thousands. Hospitals become overcrowded, essential services halt, and fear spreads among the population. Your role as a biotechnologist conclude: developing early detection kits to identify the virus, creating vaccines to protect unaffected populations, analyzing the genetic makeup of the virus to trace its origin. Traditional terrorists. Let's begin by understanding the concept of traditional terrorism. Traditional terrorists typically operate with clear and specific motives. These can be driven by political goals, seeking independence or challenging government policies; ethnic identity, representing a particular ethnic group's struggle for rights or autonomy; religious ideologies, promoting or enforcing their belief system; methods used. Traditional terrorists primarily relied on direct physical violence through conventional weapons like bombs, targeting public places like markets, transport systems, or government buildings; firearms, used in assassinations or mass shootings; physical attacks, ambushes and hijackings to create fear and chaos. Example: the Irish Republican Army. Motivated by political and ethnic ideologies, the IRA fought for Northern Ireland's independence. They frequently used explosives to damage infrastructure, such as railways and government offices. Their actions were targeted, aiming to pressure political entities into negotiations. Traditional terrorism, while highly destructive, often had localized goals, and their methods were focused on specific targets within defined regions. New terrorists. Now, let's shift to the new face of terrorism, which is far more complex and global in scope. Key characteristics. Technology-driven. Modern terrorists leverage advancements in technology to amplify their impact. They use tools like cyberattacks, drones, and bioengineering to reach their goals. Widespread intentions. Unlike traditional terrorists, who often had localized objectives, new terrorists aim for global disruption. They do this to instill fear on a larger scale and target interconnected systems like health infrastructure, economy, or global communication networks. Weapons of choice. CBRN weapons. Chemical, biological, radiological, nuclear. Example: cyberterrorism linked with bioterrorism. Imagine a scenario where hackers target a country's health system, disrupting its ability to respond to a biological attack. Terrorists could simultaneously release a bioagent and spread misinformation online to cause panic and confusion, making it difficult for authorities to respond effectively. This new form of terrorism is far more dangerous because of its reliance on interconnected global systems and its ability to use modern tools for maximum damage. Detailed explanation of examples. Traditional terrorism. The IRA's actions were confined to specific geographic areas, like Northern Ireland and the UK. Their goal was to pressure governments into granting independence or addressing political demands. New terrorism example. Hackers access hospital records or disable healthcare systems, creating delays in patient care. Simultaneously, a bioagent like anthrax is released in crowded areas. Through social media, terrorists spread misinformation, causing panic and overwhelming hospitals. The combination of cyberattacks and biological threats amplifies the damage, far beyond what traditional methods could achieve. Conclusion. By understanding these two distinct forms of terrorism, you, as students of biotechnology, can appreciate the evolving nature of global threats. This knowledge equips you to anticipate the challenges posed by modern terrorism, innovate solutions such as advanced biosensors, vaccines, and cybersecurity measures to counter these threats. Modern terrorism demands an interdisciplinary approach where biotechnology plays a pivotal role in safeguarding society. All right, students, let's start by understanding nuclear weapons. These are incredibly powerful and destructive devices, and their mechanism lies in how they release energy. What are nuclear weapons? Nuclear weapons release energy through nuclear reactions. There are two main types of these reactions. Fission. This involves splitting heavy atoms like uranium or plutonium into smaller parts. Think of it as breaking a large puzzle into smaller pieces, but in this case, it releases a lot of energy. Fusion. On the other hand, this combines smaller atoms like hydrogen to form a bigger atom. Fusion releases even more energy than fission, which makes it extremely destructive. So, why are these weapons so concerning? Let's explore their impact. Immediate impact. When a nuclear weapon detonates, there's an intense explosion that can destroy an entire city in seconds. The heat generated is so extreme that it can cause fires over a large radius. Radiation exposure can harm humans, causing what's called acute radiation sickness. Long-term impact. Radiation from these weapons can stay in the environment for years, contaminating soil, water, and air. For humans, this exposure can lead to genetic mutations, meaning future generations could face health problems like cancer. Example, think of Hiroshima and Nagasaki during World War II. Over 100,000 Hiroshima and Nagasaki during World War II. Over 100,000 people died instantly, but many more suffered from the long-term effects of radiation. The devastation caused by these weapons is why their use is such a serious global issue. Chemical weapons. Now, let's discuss chemical weapons. These are very different from nuclear weapons because they rely on toxic chemicals to harm people. What are chemical weapons? Chemical weapons are substances designed to kill or incapacitate. Let's break them into categories. Nerve agents. Example, sarin and VX. These disrupt the nervous system, causing convulsions, paralysis, and even death. Think of it as short-circuiting the body's control system. Blister agents. Example, mustard gas. These cause severe burns on the skin and in the respiratory tract. Choking agents. Example, chlorine gas. These affect the lungs, making it difficult to breathe and can lead to suffocation. Now imagine the impact. Chemical weapons work fast, causing immediate harm. However, their effects can linger in the environment, contaminating areas and creating long-term health risks. Example, one well-known incident is the sarin gas attack in Tokyo in 1995. A terrorist group released this deadly nerve agent in a subway station, killing 13 people and injuring thousands. This event shows how dangerous and disruptive chemical weapons can be in crowded areas. Radiological weapons. Next, we'll look at radiological weapons, or dirty bombs. These are different from nuclear bombs because their main goal isn't massive destruction, but spreading fear and contamination. How do dirty bombs work? They combine regular explosives, like dynamite, with radioactive materials. When detonated, the explosion spreads radioactive particles into the surrounding area. Why are they dangerous? Unlike nuclear bombs, dirty bombs don't cause immediate widespread destruction. Instead, they cause panic. People fear radiation, even if the levels aren't deadly. Contaminate areas. Cleanup can be expensive and time-consuming. Disrupt economies. Think about a major city being evacuated because of contamination. Businesses would close, and daily life would be severely disrupted. Example, while we haven't seen many dirty bomb attacks, experts warn that they could be used in urban areas to create chaos, even without causing many casualties. Preparedness and response. So, what can we do to protect ourselves from these weapons? Let's talk about preparedness and response. Early detection systems. We have advanced technology, like sensors that can detect radioactive materials or harmful chemicals in public areas. These systems act like early warning alarms, helping us take action before an attack causes harm. Protective gear. Have you seen hazmat suits? They protect people working like early warning